to look at inheritance and polymorphism and then get into assignment 4. So my hope is that we are able to get through these topics and they make absolutely complete sense. So you guys have been dealing with assignment 3 so far, and some of you have sent it to me and some of you are in the process of. So the process of looking at inheritance was parent and child class. And I had started stitching together a small example to give you guys an idea of how this actually works. And I guess we will continue with either that example or just write a new one. Because once you understand inheritance, then we can quickly move to polymorphism, but understanding inheritance is very important. So inheritance says the properties and methods from a parent are shared with child, are inherited by child. And what does that mean exactly? Child just has to, so we'll create a public class called parent. We will literally call it parent. We will set up an instance variable, and there is the parent constructor that will set A to 0. And we can go ahead and maybe write a print method, and that will print the value of A. And since we only like to use printf, we will continue the ritual. And then we print the value of A. Then there is a child class that extends parent, and it can declare its own properties. It can have its own constructor and its own way of initializing the object. So by using the super keyword, I'm calling the default constructor of the parent class. I'm calling the default constructor of the parent class.
Oh, yeah. Sorry, this might be a stupid question, but if you don't have an access modifier for a global variable, does it automatically default to public?
No, it defaults to default, which is different than public.
So, what has access to it at default? So I know that all the methods and stuff have access to it at default, but
it's greater than protected, but less than public. I need 2 more weeks for that topic.
oh, okay, cool.
But I want to give you the answer to the question you're asking,
Sure.
right? But I'm still focused on inheritance. So let's not take away from that. So super we okay? Stay focused. Super is calling the constructor of the parent. Super refers to the parent. Okay? So, super refers to the parent. Then, child will have its own print method. And the fact that the method has the same signature, it's being overridden. Means child has same method in child has same signature as parent. So now we can also understand the definition of self-contained. What does that mean? Parent has its own print method, it's self-contained, it's printing itself. Child can call that print method of the parent, exhibiting its reliance on the parent, parent's self-containment. You can have dependencies with each other. One moment. You can have dependencies with each other, right? But if I have my own properties, I should have my own methods for giving access to those properties. That speaks to self-contained. And independent is that I have all the properties I must have and I must not depend on any other class for that. Because I think we started talking about the definition of an object 4 weeks ago, and I said, self-contained and independent will become clear down the road. Now is down the road. Okay? You are self-contained if you are providing all the access methods for the properties you have. And you're independent, meaning you have all the properties you will ever need to define yourself as an object. So, my reliance on the parent class is with super.print, because hey parent, you have your own print method, you have your properties, print them. And then I will print mine. So I will say all that with a B. Why? It's just one additional line, right? So the point here is, child has its own way of doing something, right? And what happens with inheritance, guys, is your software gets marginally better as you use inheritance, as you can see. One second.
So, alright. So the super only calls the doesn't call the topmost parent class, but just calls the one directly above it, right? So if you have a bunch of classes extending each other, the super will only call the one right above it, right? It won't call it all the way up the hierarchy.
Right. So just to repeat the question, super refers to, does super refer to the immediate parent or does it refer to grandparent? It refers to the immediate parent. You can write access methods. You can also try and do something like super.super.super. It's not recommended because you'll make your code really ugly.
And then in your parent class, let's say you have two constructors and one of them takes in like an argument or two, then if you call super and put in like an argument or two, then will it refer to the constructor with the arguments?
Yes.
Alright.
So just again to repeat the question, if we have an overloaded constructor, we call the overloaded constructor using the super keyword, and the answer is yes.
This one is like you don't want to confuse with print statement, that's the whole concept. With the A, like doing the super print.
Are you saying why do we have super.print? The reason is to call the print method in the parent. So I don't have to write the printf again. And it's also speaking to the parent being self-contained. It should print its own properties. The child should not. Even though child has access, it shouldn't, right? So folks, we have talked about using extends. We have talked about usage of super keyword. We've also talked about overriding. This one example covers all the concepts you need to know for understanding inheritance and polymorphism. So I'm trying to make the problem or the example very brief, so you don't have a lot of code to review to understand the concept. You of course will end up writing longer programs, and that's just how life is. So now let's keep this parent and child in perspective and start writing a driver. So somewhere in name, we have let's deal with the easy stuff first. This is pretty easy to understand. Parent P1 equals new parent, object and reference. P1 is of type parent and object is of type parent as well. And the properties we will have are A and this constructor and method, and that's it. Then we can make child C1 equals new child. And now C1 has what? How many properties does C1 have? C1 has A and B. Yes? And when I call the print method, will that call the print method of the parent as well? Yes, because that's what super.print does, right? So
C1, the child that you created, is P1 its parent? Is it a specific object that is the parent, or is it the entire class that's the parent?
C1 is an object, and the way to look at it is that it got some of its class definition from the parent. When the object was created, new child, it got all the properties from the parent.
But did it get the properties from P1 particularly?
No, P1 has nothing to do with C1.
Okay.
P1 is a separate parent object. C1 is a separate child object. It just so happens though that there is a memory location called A in child. There's also a memory location called A in P1.
Okay, but those two are separate.
They're just separate objects. They have nothing to do with each other. They can exist independently as normal citizens in JVM. Right. They don't have to coexist. We're making Java objects live. Okay? So, while all of this is nice, we can also say parent P1 equals new child. But we cannot say child this is a compiler error. So an instance of child, when I use the word instance, I mean the object, can point to an object reference or pointer type. God forbid I use that word in this course. Right? P2 is a reference type. It contains the address. So the reference type of type parent can point to an object of type child, but not the other way around. You can't do this. You can't take a reference of type child and say parent can point to it.
So that's,
One moment. I think your question will be answered. So P2 is the parent, and it can only see what it provides to child plus overridden methods. So I can definitely say P2 dot A equals 55. If I say P2 dot B equals 65, that's gonna be an error. Because P2 cannot see that. And then if I say P2 dot print, right, it's gonna look at the type of child, the class type for child, and load that print method. So this will print the properties of, I'm sorry, it'll use the print method in child class. You guys get that? Question, please.
my question.
Fantastic. Yes.
Why would you ever want to write parent P2 equals new child? Why not just make a child P2 instead? Because
Right, so good question. Why would you want to do this? So here, let's put that in your notes actually, because then I can ask you in the test, right? Why do this at all if you can do this? It's a very good question. The answer is polymorphism. And I'll explain this. Give me a couple of minutes. It'll make complete sense. So the idea of polymorphism is what? One word has many meanings. Right? You can think of all the words in the English language, good or bad. They have different meanings. Just think of the good ones, just to keep a positive atmosphere. Music is polymorphism, right? Human. Play the music. That's, so if my wife says play the music, what does that mean? Indian classical? You want me to play the guitar? I don't know how to. What? Polymorphism. So what it means is you're just calling a method and leaving the implementation of that method to the class that you're working with. Do you understand? Is that last comment clear? So if I say to all of you musicians in the room, and let's say you all know one musical instrument to play, you know, and you guys have different instruments that you can play. Guitar and sitar and harmonium to piano to whatever. I don't even know all those names, but. So now I say, now all of you have overridden a method, play music, and you write you're responsible for your own class and you say, play music, I will play the music the way I want. If I know sitar, I'll play that. If I know guitar, I'll play that, and so on. Right? So I walk into the room and I call a method, play music. And God forbid if there are 10 different musical instruments and you guys are all singing your own song, the play music will be very noisy. If you're doing print lines, that's okay. But if you start playing, I'm going to run out of here. Because if you play 10 instruments that are not on the same cadence, there is a problem. Polymorphism. So, overriding has something to do with polymorphism. So, and in answering your question, I'm asking this question. What does overriding have to do with polymorphism? The fact that you have a same contract, same signature, and different implementations enables polymorphism. And I really hope this last comment makes complete sense to you guys. Right? So now the fact that I can do this, I can take a reference of the parent and I can call, right? I can access overridden methods, right? So let's implement, or let's show you guys polymorphism. So I think I should leave this up above here as error. So finally we get to the polymorphism. So I can say a1 of 0 is equal to new parent. You guys have done this before? Are you all familiar with array of objects, stores? That was probably enough experience creating an array of arrays. And I promise you will do more of that. Memory management, right? A1 of 1 is equal to new child. A1 of 2 is equal to new child. Right? So now we say for int I is equal to 0, I is less than a1 dot length, I plus plus. A1 of 0, no, A1 of I dot print. Right? So, who are you? I am of type parent. I will call the print method of parent. Who are you? Instance of child. I will call the child prints method. Who are you? Instance of child. I'll call the child method. So it's like this for loop is like me walking into the room and saying play music. And you all are then going through introspection and saying, okay, guitar, harmonium, sitar, whatever. And you start playing, right? That's what your Java objects are doing. Oh, my type is child. Let me go get my print method and print when it's my turn. And so on. And if we were to write this in a multi-threaded environment, we could have these threads printing all at the same time. So for that, you have to come to 35B, because I'm not going to cover multi-threading right now. But if I wanted to just print, this is going to work one object at a time. It's going to go sequentially, obviously, right? It's the same thing as turning on the light switch in the room. And if all these lights were child classes of the parent light class, and we wanted Las Vegas effect in the classroom, and we had different types of lamps, one switch is polymorphism, turn the lights on. At that point, every light object is saying to itself, oh, turn the light on, how do I do that? Am I a tube light? Am I a bulb? I don't even know different types of light, but let's just go with those two, right? Polymorphism. So, you really need to understand this deeply. Why? Because you have to do the implementation over and over again in your code. And when you think of opportunities for using inheritance or polymorphism, there really has to be a connection between those classes. There has to be some commonality. Just like the books keep telling you, the plant kingdom, there is a parent class and then there is, subclasses, right? Those are connected. But don't connect objects that are not linked together. That is where you have to apply your logic and say to yourself, what are some common properties that belong to the parent? And then I can extend those to make a child class. And the next question would be, why do you want to deal with polymorphism if it's so much work, right? Why have polymorphism? That makes another good exam question, right? Extensibility, reusability, right? I mean, I think a very complicated question is, what is extensibility? Well, I've created a book, right? I want to build the next version of the book. So it's a child because there are 10 concepts that I realized, now I have 2 more. So I'll create 2 more chapters and do a new revision and sell a whole new book. And then I keep doing that every 6 months and keep making new child objects, and that's extensibility. There is also reusability, right? Because if I extend the parent and then it has a child and a grandchild and a great-grandchild and whatever else you call to the great-great-grandchild, you can keep having that hierarchy, right? And the child object that is at the lowest level has the most functionality, right? So, extensibility and reusability, because the child is reusing the functionality of the parent. So, and that is evolution, guys. Isn't it? That is evolution. Think about it. I mean, I want to go back to biology 101 and maybe take that class one day, because I understand evolution as was described by Darwin first, and I'm not an expert, but I understand evolution from software perspective. Because my software evolves and it gets better, and mutations happen and things get better and better and better as I keep extending classes. Nature is doing that too. And it's time for me now, I guess, to go back and understand what nature is doing in biology, animal kingdom and plant kingdom. These topics are really related. I just don't want you guys to understand overriding and extends and calling those methods in this way. This is a very simple thing. I mean, from a coding perspective, or from an implementation perspective. It gets nicely complicated in your physical world, right? And you as designers using object-oriented design, this as a pattern, when injected into your software systems, it makes you a fabulous designer. Now, if you're writing code in PHP or some non-OOD languages, none of this applies. You just start, then you just write scripts like you do in HTML, right? So all of this discussion is futile at that point. But if you end up implementing OOD, right, you can do amazing things with both the concepts of extensibility and reusability. I mean, there is obviously a whole philosophic thing that comes around inheritance and polymorphism. So I mean, you know, in the physical world, you could ask questions like, why do people like to have kids? Right? Why create child classes? That's like, why do you want to have kids? Right? So, I won't try to answer that. That is a polymorphic question that you all can figure out on your own. And oh gee, I got recorded. I figured that out for myself. But that's polymorphism, okay? An overridden method that everybody has to go through at some point in their life, you know, that, hey, is that a yes or a no, and so on, right? So. Okay. Any questions on polymorphism and inheritance? Or have I confused you guys completely? I have? What are the questions? Or shall we go through the lab assignment and maybe that will start to, things will start becoming more clear. Okay. Did I see a hand go up?
Yeah, I had a question.
Okay.
So I just about OOD overall. So is object-oriented design as like a paradigm? Is it just like a class extending another class, a class creating objects that are slightly different from one another, and the kind of relationships between that? Is that like encompass everything in OOD?
No, that's just the starting point.
Oh, okay.
So, excellent question, right? We have learned 5 patterns so far, 5 relationships. And his question is, I mean, if you think of inheritance and polymorphism, you have a parent class and child classes that are a variation of the parent. Is that all that we need to talk about in object-oriented programming / design, or design / programming in that order? And the answer is no, this is just a starting point. So we learn how to create a class, and we learn how to build objects. Then we learn about object relationships. And the 5 relationships that I have tried to bring to realization are encapsulation. Because when I have the ability to hide things and encapsulate, that makes me self-contained also. Right? I'm kind of pushing the point of self-containment, right? So when I encapsulate, I can hide my thoughts, I'm self-contained. Because then the world doesn't need to know about my thoughts, all the thoughts, just some of them. So I have encapsulation, I also have containment, objects contained in other objects. There is also association, which is passing by reference, one object passed by reference to another. And then there is inheritance, which is redistributing properties from parent to child. And then there is polymorphism, using overridden methods to do fun things. How does overriding enable polymorphism? If I do end up asking you guys that question, make sure you answer it with this code. If you just write that code with, you know, parent and child classes, you'll get full points. Because, you know, sometimes words isn't the best thing to explain code. You just read the code and it is self-evident. Is it? When you look at that code, at least for now. Because people say, well, you know, things seem easy when you describe it, and then later on we look at it and it's like, oh. That's when questions come up.
So if we were to use that as an example, should we like define that child?
Yeah, you should define parent.
and all that. Alright. And like the print methods or whatever, we would we like define that the parent has? its
Make
own
sure you
method?
define overridden.
Oh, okay.
Make sure you write all this on the, make sure you write all this too. For this to make sense. Yeah? Assignment 4. So you have two programs. Here, let me do this. 1 second, guys. Okay, so let's talk about assignment 4. So the first part is an attempt to coach you on implementing inheritance stepwise, in baby steps. So it will take longer to read this paragraph than it would take to write the code and just read that code, right? So, does that make sense? So it says create a class called savings account, then use a static variable to store the annual interest rate for each of the savers. You already can tell, right? Public class savings account, static variable, interest rate. Each object has a private instance variable called savings account. So obviously if you create something private, savings balance, you're going to do what? You're going to encapsulate. You're going to write getters setters. Then you will write a method called calculate interest rate, calculate monthly interest. Is that an instance method or a static method? Based on the highlighted description, you don't have to look at the whole thing. It should be an instance method, okay? And it tells you how do you compute the interest rate, and then you add that to the savings balance. Then you have to write a static method, modify interest rate, that sets the annual interest rate to a new value. Interest rate is static, so therefore there is a static method. 1 moment please. And then you end up writing a driver to create account objects. You can change the interest rate and call these methods to test things out. So parent class is about 15 lines of code, the main is probably another 10, with comments. Object-oriented programming is really easy. You don't have to write a lot of code, you really need to understand the concepts. Your question, please.
So if you created a class and it was just all static methods, then you wouldn't really be able to create an object of that class, right? Because you wouldn't because everything would already be stored in the thing. So if you wrote let's just say I wrote thing and then I made it a static method inside, and then I said equals new, it just wouldn't work, right? Because it wouldn't have anything. What would work? But then you can create an object of it.
So good question. If a class has a bunch of static methods
And no instance.
and it has no instance variable, maybe I should ask this on the test. This will be another good question. You have a class with bunch of static methods and you make an instance of it, and will that instance still work? Totally. There is a default constructor, right? The object is empty. It has no instance variables, it has no instance methods, right? By the end of this quarter, and this is a statement I'm making and I'll prove it, that the value proposition of writing static methods is very low, very little. In OD, we should stay away from thinking about static variables or methods. This example that you're working on, assignment 4, is going to help you understand the meaning of static. And later on, why not to use it, okay? Static variables to me are like global variables, right? But to say today that don't use static variables will sound very odd because, you know, there are static things in life, in our physical world, like, you know, the projector and the projection screen and the temperature in the room and the light in the room, right? But if you were to talk about yourself, the human class, and you were to take all those static variables and define those as instance and create your own values, then you can take that data with you. Now the question is, why would you be interested in that data? Like, I'm an instance of a human class, I come to class. If you can take your own, if you can have your own instance of what is being displayed on the projection screen as your lecture notes, and it's not shared, granted it's going to take a lot of memory, but you'll have your own notes to refer to at any point in time, and even if you change them, it's going to be okay, right? So that example hopefully provides you a functional reason for why you want to do that. Because the future of programming is that objects are not living in one Java virtual machine. Objects are on the move, like human objects are. I mean, you as an instance of human class, you are on the go all the time. I mean, think about it. You get up in the morning and until you go to bed, you are on the go. You're on the move doing things. So objects living in the JVM, in the distributed programming world with cloud and the applications and the interactions that Java objects go through, it's the exact same thing. So when you put everything as an instance variable, that object can take it with it wherever it goes. And that is very powerful, and that's where the idea of static dies, right? Okay, let's go through the assignment so you guys can probably start working on assignment 4 and ask me questions in class. How is part 1 of exercise 1? Does it seem pretty easy?
Alright.
It's like writing the human class that you wrote, or personal information class that you guys wrote in Lab 2. It's like that. It's not complicated yet. Yet. Now let's look at part 2 and try to process this.
Oh man, it's fine.
It's not super hard.
It's super hard.
No, it's not.
Really, really hard.
I disagree. Nothing is hard. Hard, you know, thinking something is hard is just a frame of mind. It was the same thing when I was learning to drive. I mean, it felt really hard to drive a stick shift in UK. Streets are very narrow and the cars are so small. And there are hills all over the place. And if you go uphill in the first gear, you know, and you're not making any money and you have to pay somebody £8 an hour to teach you. This was 35 years ago, man. Not 35, 30 years ago. Right? It seemed hard. And I drove in the first gear for 6 weeks. 2 lessons per week. So I paid 12 hours times 8 to drive in the first gear. It seemed hard. And today I drive a stick shift like there's no tomorrow. I mean, I can drive really well. Give me just a good car. 0 to 4 in, or 0 to 60 in 3 seconds. Cool. First year. Okay. Write another class special saving that extends savings account to pay interest rate of 10% on accounts that have balances more than $10,000. Makes sense, right? Special saving extends savings. If the balance is more than 10,000, we pay 10% interest rate. So we will override the calculate monthly interest rate method. So if the balance is more than 10,000, we pay a higher interest rate. Then we also need methods to deposit and take money out of the account. Are we going to put those in child class or parent? We should put it in parent, because every account needs deposit and withdraw. Then you can write a driver to test the special savings class. Make a few deposits and withdrawals after the initial, and then show the interest earned. If the balance is above 10K, you should pay 10%. If it's less than 10K, you should pay lower percent, whatever the regular savings account is. Now the thing is, interest rate is a static variable. And that's what will make this lab fun, or hard, as you might put it. So let's play with that, right? The next one is a very small lab. You're designing this thing completely. So there is ship, cargo ship, and cruise ship. Do you see any relationship between these classes?
Yes.
A ship can be a parent of cargo and cruise. So I'm asking you to design these yourself. Create a ship class. What kind of properties can it have? I don't know, the shape of the ship, the length, the width, the height, the weight. Where is it originating from? Where is it going? Maybe we can start thinking about Google Maps. You're almost ready for that, by the way. Start using Google API for a bunch of Java things. So maybe not yet. So you try and get as creative as you want to get with your ship class. I would recommend don't go overboard. 3 to 5 properties, just leave it at that, right? Then you have cargo ship. What are some attributes of cargo ship that are unique than ship? Yeah. So you have to figure out a way to define attributes that will differentiate ship from cargo ship, or cargo ship from ship. It should have all the properties of the ship class though, because ship is going to be the parent. If you don't say cargo ship extends ship or cruise ship extends ship, then this lab is not this part of the lab is not complete. So cargo ship as containers, like you said, it's huge. You can describe the properties as you see fit. Same thing for cruise ship. Cruise ship has a pool on it. From what I've never been on a cruise ship. Maybe I should go this winter to figure out if it has a pool or not. Sorry, I'm just trying to be funny, guys. So you can think of properties of the cruise ship and add those. And then demonstrate the program using an array, using a ship array. And this will be your opportunity to help me understand that you understand polymorphism. So I'm hoping that there will be a few overridden methods that I will see in play with an array of objects. Right? And did I tell you enough on how to create class diagrams?
Yeah.
The UMLs? Is that the same thing?
You don't have to use UML.
Do we have to show how one class links to another class?
Yeah.
Oh, okay.
And you make up your own legend for that. So I think I gave you guys,
Can we use UML? You want it?
if you, yeah, I mean, you can do whatever you want. I thought somewhere I provided you guys with a reference to creating class diagrams. Yeah, there you go. Drawing class diagrams. So you draw these boxes and then you use some way to link the classes, and you can use a light arrow or a heavy arrow, and as long as you have a legend on the side that explains what the relationship is, I'm okay. So and there are basically 5 relationships you need to exhibit. In fact, 4. Because you don't really talk about polymorphism in a class diagram. How do you show encapsulation? When I declared the properties, I'm going to include the modifier. So that'll be a way to show encapsulation. If I have to show association, I can just use an arrow like that. Containment, I can draw a line and add the word contains. Extends is just a simple arrow. Okay? So in assignment 2, I did not get class diagrams from some of you. I am expecting those. And don't type those in Notepad and send it to me. You have to draw the class diagram, right? We want to get into this habit from get-go for the simple reason that it's a good habit. So I'm sorry you must have lost some points. And if you did, request is for assignment 3, draw them. If you're done with assignment 3 and ready to ship, and the class diagram isn't done, ship the code. At least the code is done, and then send another email, like doing a reply all, and I'll see both things. And then assignment 4 onwards, of course. I need the test run, I need the source code, and the class diagram. Yes?
How's the driver class associated to the other classes? Is it just a regular association?
A good question. How's the driver class associated with other classes? It's not. All it's going to do is, it actually doesn't even belong on the class diagram.
Okay.
And because it's a program to test a program, right? So who cares? I mean, you just don't put it, it's not part of the genetics of the program. It's a driver.
So how exactly do you do enum on a UML? Do you like treat it as any other variable, or?
Yeah, you just,
is there-
to show a enum on a class diagram, just show the declaration like you would any property.
Okay.
I'm hoping it'll be inside a class,
Okay.
right?
Yeah.
Please.
For assignment 3, do you require the class diagram? Yes.
We need class diagrams assignment 2 onwards for everything. So, all right, this is all for today. please continue working on your assignment 4, and let's actually do part 1 in class. Like exercise 1, part 1 and part 2, try to code them in class. So. Then everybody's listening to you. Changes for you, it has to change for everybody.